Uh, Good evening, everyone. I think am I audible? Please, if anyone can just thumbs up. Yeah, thank you. So let me join through another device. Camera will be blocked. So okay, is my screen visible? Okay, thanks. So this week was actually on optimization. So in case of C programming and assembly languages, uh, optimization plays a key role because if we will not optimize certain instructions, then there will be a lot of move and other instructions which will provide us some kind of time complexity and which we don't want. So in this week, uh, we were told about how to insert inline instructions in any kind of C program. Other than that, uh, we went through different kind of ways to write a same program. One was unoptimized way and other was the optimized way. So we found that there are too many instructions which are actually we can say redundant. Mostly these are move instructions. So we try to eliminate most of the move instructions which are redundant and try to get an efficient code in the assembly languages. So today I will first go through briefly in the topics and then we have lot of questions to do today and from last lecture something was missing. We will cover that in very last moment. And very, very thank you. I got around 173 people attended the last session in different times. Thank you for that. Hope you will continue to support. Okay, so uh, let's dive into the course. And in first lectures, we were talked about like there are multiple compilers for C. First thing is compiler. Uh, so in compiler, we have a lot of compilers like GCC compiler, C++, uh, can use that. Mostly in case of Linux program, Linux operating system, there we want to execute with command line, and in general we use this GCC. That is most famous one. Then there is Turbo C compiler. Then there is Microsoft compilers. There is also Dev C++ compiler. So something common, something different. So if we go through different compilers, there are different syntax. Okay, so like it was told in lectures also, we want to first go through inline assembly language. Means we have C code, and with that C code, we want to insert assembly language within that code. So we want to inline the assembly code with the C++ code. So GCC is actually complex in terms of syntax. That's why we actually use Microsoft Visual Studio Code compiler, Microsoft VC compiler. Okay, so there was one example that we have a void main, then we had some assignment like x is equal to 5, say, and then we wanted to increment it, and then there was some print statement and all. So if I wanted to translate this only, then we want that all other part of this syntax remain constant in C program. This thing, only this thing should get converted to the assembly language. So how we do that? We actually write something like this ASM, and within that we actually write this assembly program of this x is equal to x plus 4. So what was it like? In general, we will use it throughout. So we first move the value of x to ax. Okay. So uh, what it will do? It will actually put the value of x to ax. Then uh, there was addition. In addition, we actually added this 0x0004, and what it will do, it will actually add eax with 4, and then actually when we perform any operation, we want to store within a say variable, so eax, so it will actually store value of x, value of eax into x. So this was a little way of going through assembly program within C. So what happens actually, we for every calculation we want to store the value to the register, and from that register we perform the operation and then again store the value to the variable, and then obviously we will go through other instructions. Okay, so then there was another thing that that was data types versus assembly language type. So data types in C. So if we will use byte of data, then it is character. If we will use word of data, then it will be sort int. Means if someone doesn't know about sort int, then it's a integer only, but having a lesser limit. Or int also based upon compiler, and there is d word, so it is for long int. We store long integer or int in some cases. Okay, then there was an example like eax is equal to x into y plus a minus b. So we were given that all variable are of 32 bits. Hmm? So, and ebx we were also given like x to the power y, x or y, and yeah. So that was written like we actually did void main, and within that we assigned some values to these x, y, a and b. So like I am just giving is 1, 2, 3, 4, and then we perform it using assembly language. So for that, we first move EX into X, then we actually move Y, then because sorry, we will get actually uh 64-bit integer. Let's I move Y, and what we'll do here, EX will be given value this, and EDX, EX, X into Y should be null, I think. And then there will be addition where we will add EAX, A, EAX, X into Y plus A. And there was subtraction like EAX, B, and that will store this overall statement. So EAX will be something like that. And in next one, there was we will store it in EBX. Then we perform XOR. After that, we moved, and then and then OR, and finally we got the value in EBX only. So this was a simple example we solved in this week, and there was one way of doing loop. So like we were given jump instruction, or we want to reinforce something, or we want to apply some loop, say. Okay, so there was a question like uh, z is equal to x into y, and we wanted to perform it with repeated addition. So for that, uh, and we were given that x and y are 16-bit sort integer. So what we did, we actually took sort int x is equal to 2, y is equal to 3, and then we initialized z with a value 0, and then in the most crucial part, we actually perform XOR with the EAX. EAX, what it does, can someone write in the chat box? Means in Q&A. If I XOR something with itself, I told in last week lecture, am I audible? Yeah, good. So actually, it clears the value which is stored in EAX. Okay, so we first cleared it so that there should be no garbage value, and then we move ECX with Y. So it is kind of counter we want to assign. So ECX is a kind of counter on Y, and then we started one label or loop on that. Anand, I can unmute you all, but I have to like go through each one's doubt. So every time uh, any participant will open the mic and my flow will be diminished. So it will be better if you write, and that will be good for everyone. If there will be need, just write in the chat. I will open for you for some time. Okay. So, and I will open mic when we will solve the things. I am just revising the things so that everyone should be on same page. That's it. Uh, so in case of uh, jumping, or we can say we want to reinforce or loop on some operation, we just provide a label in assembly language, and with that label, we write all the code within that label we want to execute in a loop. So, like we want repetitive addition, so we can write like this, and it will add everything till we not provide any kind of this loop. So like for that we were given ECX, and then if it is not zero, we again go to mult. Okay, so till this counter gets zero, the value will be added. Okay, so what happens if we have say 3 cross 2? So first time it will have 3, then we will add this and we will decrement this. Okay, so it will be 6 now and it will be 1 now. Again, it will be 3. Sorry. 3 decremented to 1 plus 3 decremented to 0. So it will be now 6 and it is not 0. So it will actually get out of loop. So when it will get out of loop, we will move the value of EX to Z. So it was on 2, 2 to 1 and 1 to 0. So as it got 0, we will not add something. Then there was another instruction like x by y and x% y. Okay. So what we were told that if we will divide it, uh, we can store quotient and also store the remainder. But if we will use it in inefficient way or without any optimization, sorry, without any optimization, then what will happen? We will have to move again and again. Like if we will go uh, for each instruction individually, then what will happen that we will move EAX, comma X, then integer division or sign division Y, EAX on X, EAX on X by Y. It will provide us quotient, and as Every time we will get remainder also, and that remainder actually gets into EDX. So this was for reminder, and we actually move Z from EX because Z is actually quotient here. But if we want to execute this, we will again start over. So we will need to start over. We will do it again like EX comma X, then IDIV Y, and then we will have to store our EDX. Okay. So we if we see clearly, these two instructions are common. So we can just put it after that. But due to an optimization, we will have to do this like we will have to go one by one. So there are redundant comments or redundant code which actually affects the efficiency of the compiler. That's why we every time we want this kind of code, we want to execute a set of instructions and that to be supported by the compiler also. So what will happen here? Like for example, if we will do like this, int x is equal to 10, y is equal to 20. So what it does, it actually moves the value of x and y to a register. Like we can say it's in hexadecimal 10 will be 9, then a, and it will be 0014. Okay, so this is like that, and then there is in ZR, Z is equal to x by y, R is equal to x% y or modulo y, and what happened there that we actually move EAX with x, then integer division with y, then we move Z with EAX, and concurrently we actually transfer EDX, value of EDX in R. Okay, so what happened? We are finished within 4 statements only. That's why if compiler is efficient and we do some better coding, we can get the results in better and optimized way. That's what point we are all about thinking. And there was another question which was having multiple instructions like x plus y, then a was used, then b was given something like this. So there was int a b d, and so a is equal to x plus y, b is equal to a minus y, c is equal to b into y, and d is equal to c by y. So the problem here was if we will do some kind of operation, and the result we are using in next instruction, okay, like this, like this, and we want to show all these four values. So what will happen, each time we will have to assign different register to store different values. Like for this we can say EAX, for this EBX, ECX, and all. And for every this kind of assignment, we will have to first move, then perform operation, then again we will have to move the value to the variable. So in optimized way, what we can do that we can take all instructions together and just start with the moving the value of x to eax, and when this instruction is done, this word is done, like a is equal to x plus y is done, like add exy, we just store it, move a ex, and ex is having the value of a already here. So what we does, we can actually subtract the value. If a we want to use, we can directly subtract the value which is stored here with y. So after that we can go for this subtract ex comma y. Likewise, we can do in all the cases using the register EAX only. Okay, so this is also one kind of optimization we have used. Then there was another term that was pointer arithmetic. Pointer arithmetic. So in pointer arithmetic, what happens that if we are using pointer to some string, we are having this pointer value. Like if we like something, we write something like this, where. So what for each kind of pointer, we will add the value. If we will increment it, we will add the value accordingly depending upon the data stored. Okay, so if we will go for this pointer PA, we will have to add by 1, and for this as integer uses 4, so we will have to add plus 4. And what does it mean that each character actually occupies a single byte and each integer occupies 4 byte. That's why when we will add, we will go through plus 4. And then there was a program of string length where we were taking an string and we actually used the data stored in some location in that. So string, for string, what we actually do, we actually go through the address of the data and move that to the pointer, and then with the pointer, if we want to actually say want to measure the length of a string, or we want to print the string, so what we will do, we will add a pointer to the we will provide the address of string to the pointer and we will iterate over that, and then we will be having some count variable, and in assembly language we will go for comparing the byte. Okay, so that was like cmp byte pointer, and the value is stored at ebx and 0 comma xx. So this can be changed from byte to word or d word, and similarly if we will again if we want to add something in ebx, we can add 4 or 2 or 1. That depends totally on the data type we are using, we are considering. Then there was a question on swapping. In that we were given first the temporary variable and we swapped with temporary variable, but the problem was that in memory space it was swapped, but in the main function it was not swapped. That's why we went for the final swapping kind of instructions, like where we used the pointer to the address and we swapped the addresses. Okay, so earlier it was something like we were having A, B, and we wanted to do something like this. But what we did, we actually applied push X, push Y, pop X, and pop Y. So what happened that in this, say this is memory space, it exchanged, but it hasn't exchanged in this main function. So for changing it in main function, what we did, we actually provided the address to A and address to B, and using that we actually swapped these two using the pointer, and finally in main we were able to change the values which we wanted to swap. So I think this much was covered, and the last thing, there was assembly instruction about move EAX, comma X, then move EBX, comma Y for swapping. And what we did actually is we pushed EAX, then we push EBX, and then we pop. What I'm writing is actually the content stored in EAX and EBX. Okay, so it is possible, and it was told that how it is possible, and directly providing pointer is not possible. That will be told in upcoming weeks. So this was all from the theory side, which was covered in this week. So if I say, we were first told about which kind of compiler we are considering. So we considered MSVC due to its less complexity. Then why we are using? Because we want to use this inline instructions, inline assembly code. Inline means we want to write some assembly code within uh, this C program to make it faster for certain instructions. Then there were data types. Uh, for byte, one byte is used by character, word is used by int, and d word is used by long int. Then there was example of how we can do it. There was another thing that if we are performing x into y, it is done if edx is 0 only, y it is not 1, it was homework. And then there was the jump reinforce, where we actually apply the counter, and we apply some condition statements. So when that condition gets true, it goes to some level, it gets false, it comes out of this loop. And then there was efficient use of the idiv and imal. And then there was pointer arithmetic, where we actually swapped two numbers using the addresses instead of using the actual values. So This was all for theory part. Now coming to the questions. Okay, so this is the first question where we are giving this program. We are having void main, then we are having x is equal to 5, y is equal to 2, a is equal to 4, b is equal to 6, and we are given some assembly codes, and we are asked for what expression will the register EAX bear immediately after the execution of statement 11, means after completion of this code. So it should be, I think, it was not mentioned somewhere. It uh, should be 4 or 8 based upon compiler for D word. I'm noting it. I will confirm you for MSVC. Yep. So just okay. So this is the questions. I think you all have went through the lectures, and today I also covered. So what will the answer of first? Take 2-3 minutes and then write, solve it. Write on the Q&A. Just take, let me drink some water. Okay, we got one answer, 3. So, as a hint, I can say just write the instructions. Okay, let me explain. So, it's kind of inline assembly question where we have to actually start with just a second. Protocol. Okay, sorry for the interruption. So in this question, we are asked about what output we will get that will be stored in the register EX as uh, we are using inline assembly. Okay, so in inline assembly, we are given these kind of instructions, and what they are asking that at the end of these instructions, what result will be stored in this EX. Getting my point? So how we will calculate it? Let's solve it. So in this, we are given int x is equal to 5. I'm writing it because the next question is actually related to this only. B is equal to 6. Is it? Yeah, 5246. Now, if we start from fifth instruction, what it is? It is the move EAX, comma A. It was fifth one. Sixth one is move EBX, comma X 7. Perform AND EAX, comma B. Then in eighth, perform OR EBX, comma Y 9 or EAX, comma X 10 is move EDX, comma X, and 11 is XOR EAX, comma EBX. So if we will go like this, for each instruction we are having two registers here, and let's assign the value per instruction so that we can get the final instruction in after each of the instruction in this assembly code. Okay, so in this instruction, what happened that A is assigned to EX. So A will be here. Let me change the color. A will be here. Then EBX was not having anything. In this instruction, EBX has taken value of X, and EX was not altered. Sorry. Then then there is AND of EAX with B. So AND is provided by this. Sorry. So it is now having A and B. EX is having A and B is having X. Now next is for EBX. EBX has got OR. So OR is given by plus here. So X plus Y. Okay. So EBX was having X in this, and X is actually performed OR with Y. So EBX is now having X plus Y, and EAX was not altered again. Then uh, we are having this, and we performed OR operation. Okay. So A and B plus X, and it is unaltered. And now what happened is that we have to move X in EDX. So there is nothing to be taken care by EX or EBX. Now, if we will perform XOR of EBX with EAX, the result will be stored in EAX actually. Just a second. So what it will be? It will be A and B plus X. On top of that XOR X plus Y. Okay. So after completion of instruction 11, we got this expression at EX. Okay. So A and B plus X, A and B plus X. Okay. X plus Y. If we see this one, there is X and Y, so it is discarded. There we are having OR. This is also a representation of OR only. So yeah, it's a problem with the question itself. They should actually provide it. So in general, okay. So sorry, there was a problem. So I was telling that in some of the places we actually use plus also to represent OR, and in most of the places pipe operator is also used. Okay, or a straight line. So this is also discarded because we are having A and B or X. So here A and B or X is OR X plus Y. So it is correct. The last one, A and B plus X, but it will not be like that because there should be a bracket. Okay, so it's also wrong. So answer is C or 3 anyway. So Sai Kumar, you were right. I think Lavanya, it's now clear. Okay, for second one, uh, the hint is that you will have to assign the binary equivalent of X, Y, A, and B and perform the operation. Just let me know the answer in 2-3 minutes. I request everyone to just try these questions. These are very simple. Actually, it's kind of and or we are performing some logical operations on some variables like that only. Uh, I think NPTEL has shared, Akshit, NPTEL has shared a link. There you will get my Excel sheet where I upload these lectures, these things on YouTube and also the other things, these slides also. Just stay tuned with the mails you get from NPTEL online courses. Any answers for second question? What value will the register EAX appear immediately after the execution of statement 11? Answer is 3. 3, 3 or let's any other answer? You have to just take the binary equivalent of each of the number and perform the operation we have actually got 2. Because in these are previous year questions and it was not clarified in the answers. It was 5. Somewhere it was written as 2. So we have to check. Okay, let me check it for you. So we are given EAX is equal to A and B or X XOR X plus Y. So X is the 5. 5 means 101. Y is equal to 2. So 010. A is equal to 4, 100. And B is equal to 6, 110. Okay. So if we perform, let's start with A and B. So A and B will be 100, 110. So it will be 100 only. So it is 100. Let's perform X and X or Y. So 101, 010. It is 111 and X is 101. So 100 and 101. It will come up as 101, 000 and 111. So it will be 101 only. And if we will perform this XOR operation, so what it will be 101. Now perform XOR, which is the color again. So 1 XOR 1 will be 0, 0, 1, 0, 1, 0. So what we have got 0, 1, 0. And if we will go with the 010. If you will convert it to decimal, it will be 2 only. I think everyone knows about OR and XOR operations. So XOR actually gets 1 when there are different digits, and actually gets 1 if there is only ones, and OR get 1 only if there is every time if there is anyone in the operation. So we have got answer as 2. Okay, so I have corrected it. Is there any doubt with this question? These two? Take 1 minute. Will not be 9, Samantha, because 9 will be like 1001, and we are having only 3 bits. If there is some case like there are 4-bit integers we are considering, then it is possible, maybe. Okay, so coming to this one, what we will get after statement 11, if we write this. Uh, which one? The second one? Okay, I am just briefing you. Uh, what we have done, we actually took, I think you have got till here. Okay, so we just took the values in binary and perform one by one operation. First, I took this, I got this as answer, I wrote it here. Then I went through this, I performed this operation, I got it here. And then we perform this, got this, and then we have these two and perform this and got the answer, then converted to uh, decimal. Okay, Sai Kumar. Now coming to this one, if we add after 11, if we add this, so we have this instruction. I am just let me not erase it. I can write it here only. If I insert these two lines, what are the lines? Move EBX. And then multiply in direction instruction. Okay. So yeah. So it is asking what will be there in EDX immediately after execution of statement 1-3. So I have got one answer. Is any other one? Anand, can you write how it's good? I've got the right answer. Yes, good. So the answer he provided is actually correct. Uh, it will store actually EDX with EX, and there will be EX into EBX. So total it will be 64 bits. That's why EDX will be set to 1. Okay. So answer is 1. Coming to the next one. Next is, please find below definition of assembly language neg. This is neg operand replaces the value of the operand with its 2's complement. The operand is a general purpose register or a memory location. Okay, so it may be memory, it may be register. We can use in both way. Uh, we are given F0, F1, N, Fn, and C variables. Analyze it for next questions. Okay, so we are given this, and we want the answer when program reaches this, means end of assembly code, what we will get. Can someone answer? A better question than this is what this program is telling about. Can someone write in the Q&A what this program is all about? If you will get that logic, you will go to the answer quickly. This one also and the next one also. Can someone guess? Wrong guess will be okay. Just guess what this program is telling. So we have a counter, we have a initial value F0, then there is one more value F1. We add it, add the value of EX to EBX. So we are doing F0 plus F1, then we subtract EBX with EX. Okay, so EX is now having F0 plus F1, and EBX is having F1 minus F0. Then we perform 2's complement of EBX and decrease the counter. And we do it till the label, and we provide Fn. We store final result to the uh, variable Fn. So it will go till it is not 0. So just I will suggest just go through uh, um, kind of one time dry run. Like just take value of n to 1 or 2, and then just print the value you are getting after it. NEG is operand here. It is given. It is 2's complement. So if I take 0, okay, say if I take 1, so F0 is 0, F1 is 1. Okay, now if I go for this 2, so N is equal to 2, and F0 will be 0, F1 is 1, and then EX will be 0 plus 1, 1, and EBX will be 1 minus 0. It will be 1. And again, we will take 2's complement of it. 2's complement of 1 will be, I think, 1 only. And we will decrement it with ECX. So actually, it will provide something like F0 is 0, then F1 is 1, and there are n times it will run. So if we will go for 2, there will be 1, then 2, 3. So ultimately, it will be actually Fibonacci series. Okay. So in Fibonacci series, we have to go for n is equal to 9. So what it will be? So let's start by doing one by one. Okay, I think. Okay, you can just write Fibonacci of 9, what it will be. That is the answer. And let's try it. The solutions, it was done with the program only. Let's- So 0 is 0, F1 is 1. Say ECX, for 9, we will go for, we provided it 9. EBX is having F0, that is 0. EX is having this 1. Now we will go to LBL. In LBL, what it will do till this uh, counter, that is ECX, doesn't get 0, it will reiterate or reinforce one by one. Okay, so first, just a second. Yeah. So first, what it will do, we actually add this EX and EBX. So let's do like this: EBX and ECX. So in EX, we had 1 already, and we are adding it to EBX. So what we will get 2 from here. No, sorry. We had EBX has 0. So it will be 1 only, and 0, and ECX is 9 currently. It is set. Hmm. So after that, if we perform subtraction, this one. So EX will remain as it is, and EBX will be, uh, we have to subtract it 1, it will be -1. Now we have to perform NEG on EBX. So that will actually provide us 2's complement of this. Okay. So what will be 2's complement of -1? Can someone write? It's a very good question. Simple one. So in 2's complement, what we do, we actually are having like this. If we are representing in 2 bits, so we are taking 9. So let's take it as a 4-bit. Okay. So if we will write 1, so it will be 0001. Okay. And if we will write something like this, it's a complement. It will be 1110, and 2's complement will be, if we will add or add 1 on it. Okay. Yeah. So 1111, or I can say it will be F. Okay. And it is 1 only. Now it will decrease ECX 8. Again, it will add something, F plus 1. So it will take a lot of time for me. Let's, if we are taking like 0 cross FFFF. So this kind of reset, and we'll again add 1. So again, there will be overflow, and we will get 1 if we will start over. So it is FFFF. If we are considering uh, 2 bits, then it will be F only. Say we are considering 4 bits only. So we are having now F, and it will again, for EX, if we will go like this, uh, we will add EX to EBX. EX was, I think, 1, and 1 plus F. If we will add 1 in this, so there will be overflow. Okay, is there any suggestion? What is the significance of line 4? Is the N? Oh, sorry, I just missed it. Yeah, yeah, you are right. And we'll start from 8. So it will go from 8, 7 up to 0. And finally, when it will be 0, it will come out. That's why we will go from say F0 up to F say 8. That will be ninth element in Fibonacci series. So again, there will be 1, and in this we will be having uh, F, F minus 1. That will be E. So it's actually got complicated. Okay, I will solve it and show the overall answer to you again in next lecture. So you also solve. What will happen again? It will be decreased by 1, and then there will be something we will have to take the 2's complement, and it will go like this only. So we will get EX like 0, then 1, then 1, then 2, then 3, then 5, then 8, then 13, and likewise we will end up to 34. So answer will be 34 here, but it will take a lot of time. So I will just solve it and show it to you in next class, the overall step one by one. Okay, just note it down and try it because it's 40 minutes left and we are having 15 questions around. Mm, Let me check. First, I will. No, it's. Yeah. Okay. So it's a little simple one. Uh, we are given this code and we are asked about in this C statement do not get compiled to assembly statement when compiled for maximum optimizations. Can you please comment it? It's a very simple one. We have to point out the instruction which is redundant and which will not be used for any comments on this question. What should be the answer? So we are given this code and we are asked about uh, which statement will not be compiled when our compiler is actually using maximum optimizations. Yes, good. Because if you see, it will first calculate S from here, then S will go to A, and then A and S both will be passed to R. So to calculate R, we will need this statement which uses S and A. And using S and A, we should get S and A from these two instructions only. This is not needed. So statement 5 is the right answer. If we will use the, yeah, it is not further used in this program, and that's why not in the program. Actually, what we want to return. Okay, so we want the value to be returned as R, and R actually takes S and A only. So if there is some statement where we were using something like P in calculation of A, then obviously it will be compiled. But uh, to calculate R, P is not even used. That's why statement 5 will not compile. Okay, now coming to this one, it is telling statement 4 was changed to A is equal to S plus Z. Let's change it. Statement 4, S plus Z. 6 is changed to R is equal to A minus S. Now, which of the following statements do not get compiled to the assembly language when compiled with maximum optimization? So answers are same 3, 4, 5, 6, 7. Which statements will not be compiled? Now we are having these two instructions and we are using the optimal compiler. So which instructions will not be used? 5 is one correct answer. There are other statements also. Just think about all the statements. Lavanya, your answer is partially correct. As you tell statements, that will be the particular word for it. The hint is we can just solve the equations. Just solve the equations and then uh, just comment what equations will not be compiled. Just start from S. Oh my God. If we start with the R itself, R is A minus S. Now we want to calculate A. If S is Z minus Y, then A is S plus Z. So R is actually Z minus Y minus S minus Z. Okay, Z will be eliminated. T will be or will always be redundant. So what we want now? Minus Y minus S. So do we need first statement? And again, Z is yeah. We are getting S from here. We are getting uh, Y from here. Do we need this third statement? No, because uh, we don't want to calculate anything with S now, which is related to Z. Z is eliminated. We can get Y and S from here and here only. Then we are having this A. A is eliminated from here. P is never used, and R is having value A minus S. That is using minus Y minus S. So 3, 4, 5 will not be used. Is there anything wrong? Just let us go again. So S is Z minus Y. A is S plus Z. So S is Z minus Y, Z minus Y plus Z, and R is S minus A. Sorry, A minus S. So S is Z minus Y plus Z, and minus Z plus Y. Z, Z are done, Y are done. R is equal to Z only. So this also is not actually relevant. We can get Z from here only. Okay. So these four statement will not be used. Yeah, R is equal to Z only. Good, Anant. Okay, so 3, 4, 5, 6 all statement will be redundant here. Statement 7 was changed to return X. This is very simple one. If we just return X from here, if it is just return X, which statements will not be used now? Very simple answer. Just write, I'm just waiting. I'll wait for 1 minute. If I just erase it and just change it to X, then now what will happen? Yeah, 3, 4, 5, 6 all will be redundant. These will not be compiled, only last one will be compiled because I am getting X from here only. Good. So 3, 4, 5, 6, 3, 4, 5, 6, and repeat it. Yeah, just comment on this question. I think it was some way covered in this. After the execution of following code snippet, uh, what is the value by which the pointer variables PB and PA are incremented respectively? So int is there, float is there. If we will increment both are pointers and both uses 4 bytes. Now what will be the answer? Yeah, 4 4. Because if we will increment it, it takes a pointer um, to the next value which will acquire same size. So 4 4. Float also takes 4. Yeah. Now, given below is C code along with its compiled assembly. Yes, Divya, right. Assembly code, maximum optimizations, analyze it and answer question 11 to 14 based upon this. Okay. So we are given this C code of array length finder. We are given a pointer like this, and we are having count. If it's not zero, means till the length, we will count it. Otherwise, there will be count minus one, and we have to return the count. Similar compiled assembly code is written over here, where we start the pointer with value 8 and array length find. There is proc, there is the word pointer. Okay, so which of the following is the purpose of assembly statement at 3? Move ECX keyword pointer PA dollar ESP stack pointer minus 4 to initialize C variable count to load the register ECX with the value of C variable count to load the register ECX with the address of C variable PA and to load the register ECX with the value in the address pointed by C variable PA. Any comment on this? What will be the answer? You can just see and just answer it. No, 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 no. It's not D. So what it is doing, it is taking ECX and moving D word pointer PA at some address pointed by C variable PA. Hmm. There is one thing. I think your answer is correct, but whenever we write it, okay, any other comment on this? Two is actually wrong. One is wrong. The thing is between 3 and 4. I want a little discussion. Address of PA or value in address pointed by C variable PA. Okay, the answer given is C actually, but I think D is the proper one because here we are using this stack pointer -4. So pointer to the address should be right. Okay, I will cross check it is C or D. Uh, According to you, it should be D. C is the given answer. Okay, I will cross check it. Okay, which of the following assembly statements implement the functionality of C statement 4? So answer is statement 3 to 10. Just keep in mind statement 4 in this. Which number statement actually uh, does this in assembly program? There will be more than one answer. Yes, Anant. Okay. Yes, you can ask. You can tell. I have permitted you, Anant. You can unmute yourself. Oh, I think due to guest permission, it is showing to me you are given the access. Okay, no problem. Just write in the chat. I'll figure it out how it is not working. Okay, any answers for this one? We are having this while statement in this code where it is implemented in this assembly code, and we will be having multiple instructions to implement it. Any cases where it is implemented? Just see the count variable where it is done. Okay, no answers. So just see. We are having counter. We have to decrease it, and we are having PA of counter here, and we have to run it till the length of array, and we are clearing it also. So it is done within this 3 to 7. Okay. 3, 4, 5, 6, 7. Statement 5 in the code maps assembly statement. This one. Uh, if someone is not getting, I am again telling The question is that this uh, is the statement, or we can say curly braces. What is equivalent of this in this code, in this overall code? Which line is actually taking care of that? Uh, okay. Comparison is done using ECX, which implies that ECX should be holding the address and PA is a local pointer inside which is address is passed. Okay, so you are telling in line number 5, we are given this comparison done using ECX. ECX should be holding the address. Yes, you are right. And PA is local pointer. Yes, inside which the address is passed. Yes, correct. Correct. Yes. So there is confusion due to this ESP minus 4. Okay. Uh, uh, I will clarify it in next class. Answer is C. Yes. Okay. So coming to this one, I am also learner, so there may be mistakes from my side also. Where it is implemented, any guesses? So it is as 13 only, where we are getting through this. Okay. Because till here we are having this uh, say we are decrementing it here. So before it, we have to go through the array length finder and just a second. So statement 5 is about starting this loop of count plus plus. So it is also given as 13. Is there any comment for this question? Not getting set wrong answer or what? I will cross check this again. Let's not waste the time in this. Okay. What will be the length here? Array length finder is this. See how it should be 3. So what it is telling, till count is not 0, we will have to count and we will have to return with -1. So if we are having, say we are having 4, so last element is 0. So how you are calculating? You are just find 0 in the array. Yes. And then it actually uh, decreases also. There is a decrement also. So it will run till this. Okay. And after that, there is count minus 1. So it should be 2. There are 3 elements, but after that, there is minus 1. Am I right? Count got implemented. Okay, okay, yeah. So if it is not 0, say we are having 1, then it will be 1, then 2. So count was 0 is initially. If I start from 1, 2, 3, and 0, the array. So we will go to this. P count is not 0. So it will stop here, I think. And there should be 1, 2, 3. So for 1, it will be 1. For 2, it will again incremented. For 3, it will again incremented. And then it will get 0. 0 in this. So after 0, it has value 3. So 3 minus 1, that will be 2 only. Yeah. Okay. So answer is 2. In statement 1 of this, if I okay, statement 1 of this is changed to this. If I change this integer to sort int, then what is the question? Then which of the following statement 5 will statement 5 of compiled assembly code will change? So compiled assembly code statement number 5. There is ECX. Okay, so I am changing it to I'm changing it to sort int, and then it is asking what should be there in ECX comma EX. Yeah, Anand, no problem. We all are learners. Huh. So just comment about it. We are having this. Yeah, it will be word PTR. Good. And it should be into 2 or 4. If it is a sort, it should be 2. Okay. So answer is A here. Okay. Because it's sort integer. Uh, Coming to the next one. No, it's a simple program. Just see and answer me. Okay, this one. Will the values be swapped? And what will be the answer? Hmm, good. Two for short. So what should be its answer? What it will print as A and B after this, and after this the return value, what it will be. If I put the value 60 and 160 here, what we will get? Uh, Option 4. Very good. Because it is somewhere, so uh, A and B are actually there as it is. So 60 and 160 will be there. And if we will return the value, if we are having X and Y, so it is swapped in memory. So what we will get from here, just see, we are having temp will be 220, then 220 minus Y, it is 60, and X is 220 minus 60, that will be 160. So it will be 160 only. Okay, just put the values you can get. So answer is D here. Quickly, uh, what is the value of C variables A and B after statement 6 executes? Statement 6. After statement 6, what will be the value of A and B? Yes, Divya. Good. For 17th question, after execution of this statement, no change. Very good. Because we are not changing anything that is happening somewhere in memory. Okay. So answer is here. Oh, sorry, this one. C. Again, after execution of 7, execution of 7, it will also be unchanged because it is happening in memory, not in main. So what answer it will be? A only. Okay. Because anything happens within the function, it will not be reflected till we actually apply some kind of uh, either addressing, or we just store the value of that function in some different variables. So, so this is the last one for today's class. I think I haven't got the quiz time. I have 3 minutes left. Okay. So, what should be the answer here? Will it be swapped? Just comment the answers. Okay, the answer is 60-60. Okay, just check it, and we will get back to this question. the starting of this next week problem solving session. Okay. So thank you all for today's class. Today's class was a little bit more on questions, but there were too many questions. I think there were wrong answers reported in the last session. So I will clarify those. So we have three, four questions for from this today's class and three, four questions from the last class. So I will, I think, cover these questions in next class for first one and this today's class also. Okay. So and sorry for the wrong answers. Actually, I got confused with the answers reported in the assignment. And this we will solve with the, I will just solve and show it to you. It will take a lot of time for me. Okay. So thanks for joining. We will meet in next week session. Is there any doubt? I know today was, I got many wrong answers. But yeah, I am also a learner, so sorry for that. I will improve next one. Okay, so thank you. I am completing this, stopping this session.